there are some philosophical problems which look more likely to be solved by scientists than by philosophers. When one asks questions like, is the mind distinct from the body? Or what is time? One naturally expects that the things that scientists find out will be at least relevant to the questions that philosophers are interested in. However, it isn't always easy to know exactly what is the relation between the kinds of things that scientists find out and the kinds of things philosophers are interested in. Particularly in the case of a subject like time, where the kinds of things that physicists do seem very remote both from common sense and from the ordinary run of philosophy. So what we're going to do today is try and explore this. Here to discuss this question with me, I have Dr. Dennis Sharma, astrophysicist from the University of Oxford, and Professor Bernard Williams, a philosopher from the University of Cambridge. Could you perhaps tell us first, what do you think is the relation between physics and philosophy? Do you think these two activities have anything at all in common, or do you think they're completely different?
I certainly think there is something in common. Granted the always important point that philosophers don't advance theories that are going to be checked by experiment. That is a very important point. But still, the distinction between the two things, I think, has been very exaggerated in a lot of recent philosophy. I think particularly because some recent philosophers have made a very simple distinction between concepts or ideas on the one hand, the sort of notions we use to think about the world, these are supposed to be the business of philosophy, and facts on the other, and it's supposed to be the business of scientists to think about facts, and therefore philosophers think about the notions and the scientists find out the facts, and this is supposed to be, you know, a complete division of labour. And this really does seem to me to be quite artificial, and for more than one reason, really. One is the concepts or notions we use to describe the world are actually affected by the facts that we discover. For another, scientists don't just, quote, discover facts, unquote. They form new concepts for describing the world. And the greatest scientific advances have consisted of forming new concepts to describe the world. This was true of Newton. It was true of Einstein, particularly in this matter of time. And I think, in fact, some of the things that used to be done by people called philosophers are now, in fact, done by people called physicists who are thinking about the best concepts for describing what they've discovered. So that's a way, it seems to me, in which, as it were, science affects philosophy. But I think there are also ways in which philosophy affects science, and perhaps that's, to some extent, our business today, more directly, because it seems to me the question of the interpretation scientists give of their facts. I mean, they discover certain things, they have theories that have certain consequences. The question arises, how consistently with common sense and ordinary, as far as possible with common sense and ordinary logical notions, can we interpret those discoveries? And I think I'd like to start really by asking Dennis Sharma here whether he thinks that some of the results that modern astrophysics and modern relativity theory have come up with aren't too flagrantly in defiance of ordinary notions or ordinary logical conceptions that people have of time. And I suppose the famous clock paradox, for instance, might be one example of this.
Well, I'd like to say at the outset that I don't set much store by common sense unless you make me change my view towards the end of this program. To take the example you mentioned of the clock paradox, just to recall very briefly what this is, it states that according to Einstein's relativity, and we now believe this to be completely confirmed by observation, if a man gets into a spaceship and goes far out into the universe at high speed and then returns, he will age much less than someone who stays at home. And if one wants to put this difference in dramatic terms, one could choose the duration of his flight and his speed in such a way that the Earth ages, let us say, 1,000 years, and the man in the spaceship maybe only ages a few days. Now, modern physicists are quite used to this particular result of relativity. Common sense would perhaps object to the fact that the two durations of the journey are different according to whether you stay on the Earth or go out in the spaceship. But that's for you to say.
I don't think anybody's going to want, nobody in any sense anyway, is going to want to defend common sense in that sort of respect. That is, if we just have a general expectation, roughly, that if you come back in a rocket, you've got to be as old as the people who were you left behind. That really is a factual expectation. For philosophy to try and dispute about that a priori would seem to me to be a terribly dogmatic mistake. I think the question is, are there some issues of principle, things about the actual logical structure of time, in which it's going to be fair of philosophy to insist upon them? For instance, suppose somebody were to ask, while the astronaut was on his way, what was the astronaut doing at the precise moment that I was shaving this morning? Does the paradox entail there isn't going to be an answer to that question?
It does, yes. In fact, according to Einstein's relativity, which we all accept now, one has lost the concept of absolute simultaneity. By that I mean that if you take 2 points which are separated in space and take an event occurring at each point, and then ask, are they simultaneous or not, these events? The answer is it depends on the observer who is trying to decide this question. 2 observers moving relative to one another will answer that question in effect differently. That is, if for one observer the events are simultaneous, for an observer moving relative to him, they will not be simultaneous. So there is no absolute sense in which those 2 events are simply simultaneous, as they would have been thought to be by Newton. So that concept has also gone in relativity. But presumably you would say that philosophers can accept that situation.
Well, I think there again, yes, and I think that what this illustrates is the very, very interesting point about how one goes on eroding parts of the common sense conception of time, or the everyday uninformed conception of time, until one can get to a point at which where philosopher starts digging his heels in on logical or conceptual grounds. Of course, what worries philosophers in particular is whether he's just digging his heels in, not because we've got to some absolute point of principle, but because he's now got to something which is, as it were, even just harder to swallow than what we've had already. Well, we've got 2 sorts of things which at least I'm prepared to swallow, and I'd be jolly silly if I wasn't, prepared to. Namely, one about the expectation that roughly everybody's going to look equally old wherever they've been, and putting it very crudely, is to be waived. So also the idea of absolute simultaneity. I wonder if we get nearer something that people feel uneasily as a real question of principle when we get to the notion of time going in one direction. Mm-hmm. And I wonder what would be a contemporary physical view about the notion of time going in one direction.
Well, if you mean by that the question of the irreversibility of time, I think a modern physicist, or even a physicist in 1900, would have said that although probably human beings working the way they do depend on time being irreversible in our own locality, it is not intrinsic and inherent to the concept of time that there be this irreversibility. Because a physicist can well contemplate, and often does for various purposes, let us take a simple example, a box which contains radiation and atoms, and which has reached what we call thermodynamic equilibrium. That is, processes are occurring just as often in one direction as in the other direction, and there's a complete overall balance. Now, time is still a parameter that the physicist would use in his description of that system, but there would be no irreversible phenomena. For every process that went one way in time, there'd be a balancing process somewhere else in the box going the other way in time, and there'd be as many of one as of the other. There'd be no way of telling which way time was going by looking at the box at one instant and then what we would call a much later instant. You couldn't, by just studying the behavior in that box at those 2 instants, tell which was the earlier, which was the later. There would be a concept called time would still be needed in order to describe the behavior of the system, but it would not be a concept that would lead to there being an arrow attached to them.
Well, now I don't understand why you call the concept that you're describing the system time. I mean, if time applies to the system, does it not mean that some things are after other things?
Well, you don't need to say which was earlier and which was later in any intrinsic sense in terms of the behavior in the box. You needn't call it time. You can use any word you like. The important point for the physicist is what the mathematical aspects of this parameter are.
But you can use any word you like, obviously, because, for instance, various nations use any word they have to use the time. The question is not what word you use, but whether it is time. And one of the things that a philosopher surely can rightly ask here is to what extent does a parameter have to be related to either our experience of the passage of time or certain essential structural properties of time, as might be included the uniqueness of its direction, might be included in that.
But I think
in order to call it time, there's the parameter in question. Sorry.
Yes, can I just ask you another question which may perhaps clear this up? And that is, you say we do need a fourth parameter. What's your motivation for saying we need a fourth parameter at all?
Well, the motivation is that we cannot adequately characterize the system without using it, because if at a different time there were also a collision at that place, we would need a parameter to, or if there were two nearby points and we wanted to ask relative to a particular observer whether these collisions occurred at the same time or not, we need a parameter to specify that, because the system is physically different if the collisions at nearby points occur at the same time or at different times for that observer. But what I think,
Yes.
where Bernard begs the question, I think, is he says, but we have to decide that whatever word we use, whether it really is time, as though there were given a notion of time before we started, which was identifiable, and then we would ask of any particular case whether the use of a word like time in that case corresponds really to time, and this is what I deny.
No, but our situation just is this, surely, that it's an absolutely characteristic philosophical situation, it seems to me, which is that if you start with the entire set of opinions about time, which, as it were, an ordinary man in the street has, then clearly some of these are just confused and false and to be discounted, as we've already seen in the course of scientific investigation. If you say that there's absolutely nothing to be taken over from this into the concept of time, we can call anything we like time, then this is obviously an absurd situation, because we just now have, as it were, a verbal misunderstanding. It might turn out, for instance, that what we've now labelled with the word time was just a certain dimension of space. I mean, for instance, the following really does seem to be a plausible suggestion, that if two things, and that's all I'm going to call them for the moment, but like, for instance, collisions of particles, are to be individuated, separated from one another by the use of a parameter called time, then it's got to be by saying that one of them was before the other.
Well, I think you've got something special to say about this, haven't you? I mean, there's...
Well, but there's something else to say about the question of before and after, indeed, but it doesn't really relate to this particular point that we're discussing, but I'd like to mention it if it doesn't confuse the question too much. This is a question which even physicists are worried whether they've gone too far. But I would like, for the purposes at least of this discussion, to take a position of defending what I'm now about to say, to try and make a case that we can strip our ordinary notion of time of rather more elements than one would normally suspect was possible, and still have enough left to have a usable concept in physics, and all that is needed, perhaps. What I have in mind is a situation which arises in certain solutions of the equations Einstein uses in general relativity, which is different from the special relativity we've talked about in connection with the clock paradox. General relativity concerns gravitational phenomena in particular. And a logician called Gödel discovered that one could have a curious universe conforming to Einstein's theory, but in a state of rotation, which had the remarkable property, he discovered, that there were closed time-like lines in this universe. What that means in more ordinary language is that you could get in a spaceship and travel out like the fresh-faced astronaut, except you wouldn't come back to the starting point simply younger than the people who stayed at home, but you could, if you chose your journey correctly, you could actually travel around in a line that was closed in time as well as space. And by that I mean you would travel first into your past and then end up at the moment you began, not just at the space point you began, but at the same time that you began.
So that instead of time spreading out in a line, just going out like that, it goes round in a circle.
That's right.
Yes.
Now,
so you could come back to the point where you started from, in time.
The point in time, that's
Yes.
right. Now, many physicists feel that this is unacceptable on common sense grounds, or even on consistency grounds, because they worry about the problem that if you can travel into your past, could you then not do things which were incompatible with the present situation?
It's not causally accessible, is it? At the time when you are, as it were, quotes in your own past, are the places where you, as I'm playing this game for the moment, first had your past, causally accessible from where you then are?
Yes, I think we'd better clear this up a bit. What have we lost by saying the thing goes around in a circle?
Well, we've lost the idea that the before-after relation goes on in the ordinary way that we normally think.
Yes.
In other words, according to this view, two events are such that one is before the other and after the other, according to which way round you go along this circle.
And is this a serious loss,
Yeah.
do you think?
Well, I'd say that it's a serious loss. I would say that as it's so far been presented to us, that it's demonstrably self-contradictory. And Dennis will have to tell me why it isn't. And it's self-contradictory for the following reason. To say that I get back to the same time is the claim, if it means what it purports to mean, the timeline's gone in a circle, which is that the event which consisted of my starting is the same event as the event that consisted of my arriving. Now, I figure in that event, and it's one event, it's one happening. That's the point about it being the same time, okay?
Yes.
Now, the first time I'm at that event, I haven't been in a spaceship. The second time I'm at it, I have been in a spaceship. So there is one event which consists of me both having been and not having been in a spaceship. And that is a contradiction.
Well,
It requires me to have contrary properties at the same time. And to have contrary properties at the same time is the definition of what it is with a contradiction.
Well, that's true, but another point is there may be a physical objection to this phenomenon rather than a logical one. It could be that in a universe that had that property, it wouldn't be possible for human beings to exist with their memories and sensations
How do you
of free
answer
will.
the logical objection
Yes,
first?
I wanted to just say that
Yeah.
there's a possible physical objection that the actual universe couldn't be one of those, perhaps.
We have a stronger objection that no universe
Yes.
could be like that. is
Yes,
what they're
that's
claiming.
right.
Well, but this is the part I don't quite see, because you can certainly exhibit such a solution. It doesn't have people in, because people is too complicated to put in a
No.
solution of Einstein's
The
equation.
point is, well, we can generalize. It doesn't have to be about people. The point is that what the solution, I mean, we're making as dogmatic a claim as might be made in the opposite direction, okay, for the sake of the argument. But the philosophical argument would go like this. No solution which formerly had this loop-like property could be interpreted as the property of time, as being an exemplification of time. And the argument is quite simply the following, that if the notion of a contradiction is the notion of something having contrary properties at the same time.
Right.
Now, if there is one time, okay, which figures at both the start and the end of this loop, there must be contrary things that are true of it and things in it. Namely, the property that they haven't yet been on the loop and the property that they have been on the loop. And those two properties are contrary to one another, and nothing can have it at the same time. But if the loop was a temporal loop, then anything that went round the loop and came, quotes, back to the same instant would have to satisfy that condition. Therefore, it's logically impossible.
Can I ask
Well,
you two questions
yes.
about that? First one is, do you accept the law of non-contradiction? That's the
I
thing.
do.
You do. That's fine. That's a relief. Right.
Maybe
okay.
a future generation won't, but I do.
So, all right, now we've got that you accept the law of non-contradiction. Now, how do you get out of the fact that, according to the loop theory, you would have to violate it all the time?
Simply because I think Bernard's language is the language that's appropriate to the ordinary concept of the way the time axis works, but would not be appropriate with a closed loop. What would be the situation here is that if you took a short stretch of the loop, then the concept of before and after would be completely well defined over that short stretch. But it's just globally, the topologists would simply say that this concept is not a global one, it's only a local one. The before-after concept breaks down globally, but it is a concept that works all right for short stretches.
Does anything keep going round this loop? Does it go round this loop more than once?
No.
It goes round it once.
I don't think that's a language that's appropriate, because if you said it went round it several times, that would be implying a distinction between being at one particular event on more than one occasion, which is supposing there was some concept of time over and above the intrinsic concept of time in this solution of Einstein's equation.
So,
and that would not be true. So you simply have that loop given,
Yes.
and there's no question that you go around that loop 35 times.
No, I
the loop
take
is
that
simply
point.
given.
I take that point.
Are you saying that there isn't a language available to talk about the loops in? Or is it that we're using the wrong one? I mean, there is a language available, but we're just using the wrong one.
You're using the wrong one.
I think the question we want to ask is, you've stripped away so much from the concept of time that we're neither of us sure what we've got left.
Well, I can answer that. Certainly the physicist regards it as his task to abstract from appearances to obtain the fundamental structure of time, and it may be that from his point of view there isn't much left of what we normally think of time. What is left is that the space-time manifold must be described geometrically in a way that makes it clear that time is different from space, and that's what Einstein did in his general theory of relativity. Why we choose to call the extra dimension, which is geometrically different, time, is because I suppose it has sufficiently recognizable properties compared with our ordinary notion of time that it seems useful to keep the same word. If only because, let's say physically speaking, because over a short stretch of that time-like loop, the before-after relation does hold. For instance, in the Gödel universe, it would actually take something like 10,000 million years to go all the way around, so that in a given lifetime, for instance, the before-after concept would work perfectly reasonably. So there doesn't seem much point in just choosing a different word for the more general concept.
Well, I think the point is that I think we might manage to agree, as it were, about this, is that it isn't, we're certainly not dealing here, very often in philosophical problems, we're not really dealing here with just the question of a word. It was just a question of whether we chose to call it time or not. It wouldn't matter. The point is that there are certain features of our experience which we call and regard as the temporal features, and which seem to be structurally related to that experience, the experience of before and after, for above all, the experience of the passage of time in a certain direction. And I suppose we could agree that the philosophical problems here are going to locate themselves in the relations between that ordinary experience and the structural features of that ordinary experience and the physicist models that you've been talking about. In particular, in our ordinary thought, we certainly regard before and after as transitive, as it's forming one series, and that if one thing is before another, another before that, then that first thing must be before the last one we mentioned. But that's not going to be true, for instance, on the closed time-like loops, and therefore I think where philosophical investigation is going to be needed here is about the relation between these topological and geometrical properties and our ordinary experience of time. And I think unless something can be said about that, there will remain a doubt, a darkness, over the question about whether those purely topological relations are to be regarded as time.
So I think what we've seen here is that it's impossible to completely separate out philosophical problems from empirical or scientific ones. And that the idea that these two activities are quite separate from each other is just wrong. Dennis Sharma, Bernard Williams, thank you very much.